While linear momentum is a measure of the quantity of motion of an object by measuring the mass times its velocity, angular momentum is the same thing, only for an object rotating rather than moving in a linear motion. So because of this, the equation for angular momentum is equal to the cross product of the momentum, the linear momentum, and the radius of its motion, which we can simplify to being the mass times the velocity times the radius. And like linear momentum, there are a lot of situations where angular momentum is conserved, and this is true even if the radius is changing, if it's moving in a straight line. But this is because when we do this cross product, we're not considering all of it. We're pretty much considering just the component that's perpendicular to the radius. So the particle's movement has to be perpendicular to the radius, and that's the only part that we consider. So it's the real formula would be the mass times the velocity times the radius, and then sine theta. So let's do an example problem involving a problem from the AP test. So a particle of mass 2 kilograms is moving in the xy plane at a constant speed of 0.8 meters per second in the x direction along the line y equals 4m. As the particle travels from x equals negative 3 meters to x equals positive 3 meters, the magnitude of its angular momentum with respect to the origin is, and then it lists some options for us. So let's start by drawing out a diagram of what's going on. So we have our axes. And we have our line 4. And velocity. So basically this is what's happening. Our particle is moving from from x equals negative 3 meters to x equals positive 3 meters. So next, because the radius is considered in this equation, we need to find what that is. And angular momentum is conserved in this situation, so it should be the same everywhere. And because of this, it'll be easier for us to take a point this particle is traveling in where the radius is perpendicular to its motion. So this would be when it crosses the y-axis. So I'll put a little star there. So you can see that that's the point we're going to use, because at this point its motion is perpendicular to the radius. So we won't have to deal with any sine thetas. So at this point, because the line it's traveling along is y equals positive 4, its radius will be 4, because the point of reference we're using is the origin, so r equals 4. Our velocity, we also know that it's 0.8 meters per second, and the last part of our equation is the mass, which we know is 2 kilograms. So our formula for angular momentum is mvr, so we're going to multiply all that together. So 2 times, that's the mass, times 0.8 our velocity, times 4 our radius, and that is equal to 6.4. So here's the math I did just now, if you can see that. So yeah, this is equal to answer D on the multiple choice, so we know that that is correct.